Hi everyone, I am Rajkamalai and welcome back to the brand new series of AI product engineering and in continuation to the system design playlist. So there is a second lecture where I'm going to talk about capacity planning for YouTube like platform. So here I'm taking example of the mini YouTube like platform, and I'm going to do the planning end to end in terms of the capacity planning. We are going to estimate from very starting till the end in terms of the storage cost, in terms of the network bandwidth cost, in terms of the CDN cost, in terms of the renewable cost for this application from day one to 1 year or 5 year or 10 year long planning, right? So stay tuned. You are going to learn many things at the end of this session. Okay, all right. So let's get started. Okay, fine. Let me select my marker. Okay, pen. Okay, so this agenda is clear in terms of the deliverables, guys. There are many things that I'm going to cover as a part of capacity planning. So this all things comes under the capacity planning. So be it the daily video uploads, these are the, these terms basically you will get to know after doing the market research. Suppose when I have to do the capacity planning for the YouTube or per se similar kind of platform, right, as per the client requirement. So I will be doing those market research, going through the Google, going through all those research papers, and even in nowadays with the help of AI tools, I can do this market research in no time, right? And there I will be able to understand what all assumptions I can take into the consideration to do the capacity planning for this YouTube like platforms. So there there are the terms like daily video uploads, because this is the platform. YouTube is a platform where a creator create the videos and they go and upload those videos, right? And if they are going to upload a video, there will be certain size of those videos. So those are the assumptions, and those are the, values I got to know as a part of those market research. Because from I mean as a part of market research, what it tells that suppose currently YouTube has 2 billion users. So out of 2 billion users, considering their trends, what is the average average number of daily video uploads? That's what they can calculate, and then they can share this data to public as well, so that they can they can utilize those information to create a similar kind of uh, architecture or system. Because those initial values are important, as there is a there is something, if you're going to build which is very new, which is not available in the market at all, then in terms of some assumptions or some of the sample size you can create, and out of those sample size you can come to these initial numbers, these initial assumption, that in your case what could be the initial number of these metrics, right? But since I'm doing it for the YouTube capacity planning, and this is widely used by everyone across the globe, and these numbers are publicly available. So that is the case where after doing the market research, I came to know about these numbers and these matrices that I need to consider for this capacity planning, and that's how you can also proceed. So in general, see guys, so these are the terms basically. After completing that, let me come to the designing as well, so that you will be able to understand it in much better manner. Okay, so storage growth per year, definitely on a daily basis people are going to create the video, upload the videos on the YouTube server. So there will be certain rate of growth of the storage as well, right? That we have to plan if we are going to create a YouTube like platform. Okay, because storage is something which is very essential and very crucial and very costly affair. So it will come into the picture that we have to we cannot neglect it. Then streaming bandwidth, depending upon the size of the data that we are streaming, because when a person from the, let me draw it so in order to make it more clear to you. So guys, as a primary activity, as a creator, right, as a creator like me, I will be creating these lectures for you for the training purpose, right? So that you can just kickstart your AI journey confidently. After creating this video, suppose I'm just recording the video for the YouTube capacity planning. What I will do, I will just record it, I'll just upload it in my channel. I will just go to the YouTube, then I will upload and make it live, right? Then I will publish it. That's how things happen, right? Upload. So there will be certain daily video uploads. Like I'm just daily I'm just uploading, let's say, two videos. So these are the numbers. These are the this metrics that we are taking into consideration to design a YouTube kind of platform, right? So this is a number that I get from the market research. So these will be the average count of the videos that uh, YouTube have noticed that these are the average number of videos that people are uploading. Suppose this is two. Suppose then average video size. Suppose what is the video I'm uploading? It is of let's say 700 MB in size, right? In that case, what is the average video length, right? After doing the market research, seeing the pattern of other users as well. So it 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 could boils down to, let's say, 500 MB or something like that, right? That will, that this is something I have tried capturing here, and in order to do the capacity planning. Then similarly, storage growth per year. So whenever I'm uploading these things and it is uploaded, it gets uploaded on the YouTube server, some storage, it will it will be occupying some of the storage from the available storage of the YouTube data center, right? So and this will keep on increasing. Uh, and because there are around 2 billion plus users and they are doing this activity on day in day night basis, so in a very fast manner, this storage is going to be consumed. So parallelly they need to make this storage more scalable. So what kind of strategies they are taking into the consideration, that is a one of the that is a one of the very crucial or important point to think YouTube like for a YouTube like a business, because they need to think if with that pace the stories are getting filled, and then in order to make it more scalable, what the appropriate strategies could be applied to serve the user need, right? So that is also we have to consider while doing the capacity planning, because we need to see what is the storage cost for the 1 day, what is storage cost for the 365 days, and then for the 5 year plan, and then 10 year plans, and all, right? Generally we whenever we do design the system, we do the planning for the 5 year. Okay, so that's the idea. So depending upon this storage things, we will be calculating the storage cost, then the network streaming bandwidth, depending upon the size of the data, right? At the end there will be the group, there will be the outer world group of the consumers who are going to consume this information. They will be having their separate devices, mobile phone, tablets, laptop, and other things. And they from the browser they will be just sitting or looking for some particular YouTube YouTube videos, right? So when they search for this thing, so if the size of the if the size of that video is too high in GBs, so in order to stream that video, in this customer device, the consumer device will take so much of the time, because that much or that strength of that capacity of network bandwidth would be required as well. So that is again a bottleneck. So how we are going to handle that thing, right? So that's where this I mean, CDN calculation, CDN is also coming to the picture, right? I mean, what if we can just avoid hitting the original YouTube server? I mean, original application, YouTube application where it is hosted, rather than if what if this information can, I mean, can someone made available for you locally, okay, in your region. So from that server, suppose you are hitting from the US server, sorry, US region. Suppose you are someone who is hitting from US region, okay, and that is hosted on Mumbai in India. The actual, suppose, just I'm telling you to just assume it, that YouTube application, however, it is originally hosted in the USA, but to make it to explain it with the help of this example, I'm making the assumption that this YouTube application is running on in Asia region, hosted in Mumbai location data center, right? Suppose uh, this we are hitting this original application, right, which is hosted on Mumbai, so it will take so much of the time. What if through some arrangement, some system, we can I mean, we can serve our customer US regions customers from nearby edge devices itself. So that's where the CDN, content delivery network, I mean, concept come into the picture, right? So rather than hitting this original application hosted on the Mumbai location, it will this edge servers will started serving this these customers, these consumers from the US regions. So that's how this network bandwidth bottleneck we can able to fix it. And even the performance aspect, where the client can ask you for the 2 millisecond latency is something acceptable, not more than that, because whenever you're going to design any kind of system, so there will be some assumptions, right? Your client can say that the performance we are expecting, it is 2 milliseconds. So there will be some plus minus delta when you're creating the first cut solution. With time, you will also do the performance tuning, some optimization on infra side, and at the code level, right, to make it more optimized. But some minor delta is acceptable, not a bigger delta. So that thing we have to keep in mind. That's where the CDN will helping you to create that kind of efficient system. And then the peak traffic estimation, how many requests are going to come on the I mean the peak season. So definitely, like at the time of some ongoing promotions, or some the election time, usually when the election results are live on the YouTube, people used to, the traffic increases at the time of cricket World Cup, FIFA World Cup nowadays even, right? The traffic is expected to be increased. So how we are going to cater those peak traffics? So we have to well equipped with that kind of estimation beforehand. If the traffic increases, generally the estimation we're taking is 3x. So if the 3x traffic is going to increase, even though our system is not going to fail, the efficient our system can efficiently handle that 3 times more traffic, right? So these are I mean, this is little bit background about the deliverables that we are going to talk about, right? Then video comes in, what do you think? Why CD and how video reaches? Let's try to understand the architecture basically of the YouTube underneath. Okay, so they are basically uh, let me jump to there. Yeah, so guys, I have created this beautiful document to make you understand how underneath system works. Okay, okay, all right. So in order to explain you guys what happens, so a creator creator will upload a video of certain, let's say a 12 or 15-minute long video of 1080p pixel or video quality with 8 bit rate. A bit rate is something that defines the quality of the video. Higher the bit rate, higher the quality of the video. Okay, that's how you can remember it. Generally for the 1080p grade video quality, the bit rate used to be 8 bit. Okay, so the creator upload the video, this is the original video, then it goes to the ingest storage. So basically when the creator will be uploading the video, suppose this is the 700 MB video, and so underneath what YouTube does, it creates the chunks, small chunks. Suppose chunk 1, chunk 2, chunk 3. Here let's say 200 MB chunk it has created. This is for the example, guys. However, it generally creates a lower size chunks, right? The idea is it creates chunks. It is not going to upload the original video as it is in one shot, and then the remaining 200 MB, then chunk 4. Okay, why YouTube is doing all those stuffs? Because due to some network outage, network disconnectivity while you are uploading your video, right? So what will happen in general if you are going to upload as a one video in one shot, the upload fail will fail, and you need to upload fresh upload from zero MB till 700 MB. Okay, while if you're dividing into the chunks, right? Suppose it got failed. Suppose the first two got successfully got ingested, and for the chunk 3 it got failed. So next time it will resume from the chunk 3. It will not again going to ingest chunk 2 and chunk 2 and chunk 2 and chunk 1. Okay, so that's the whole idea, to make a process more efficient. And when it got ingest, so this temporarily storage, it goes to the temp storage. This is the temp storage basically, and this storage is known as ingest storage. Okay, that's what I have mentioned here. Then there is a underneath, I will I will say the magic factory. The magic happens here. This is the brain of the YouTube, where all the heavy lifting is happening, transcoding form. What happens underneath? There is a concept of adaptive bitrate, ABR. Okay, and what it does, suppose I have uploaded 1080p video, it will create a many different video of different video quality, 140p, 240, 144, 240p, 360p. Okay, then suppose 480p, 720p, then 1080p, then 4K, many HDR, all those steps. It generally does. So it, from the one single file, it creates a different version of the files, right? This is one thing it does. Then it does the decoding, it just analyze and try to understand what kind of content it has. Then it done the resizing, resampling, all those steps, right? So creating the different resolutions, that's what I have mentioned. And as a next step, what it does the compression codec as well. Okay, so in the compression codec, uh, so there are different techniques basically. uh, there is a one technique, the older one, the legacy one, which generally uses for the older devices, okay, or older browsers. That is H.264. So as a part of C, the underneath concept is like a compression. Why you are doing using the compression codec? To decrease the size of these videos. because if you're going to store in actual definition of the video, then the size will be too much, the storage cost will be I mean will be too much in that case. So idea is to just compress using a different technique. So this is the legacy one, generally the videos which are not viral or new one, or the running on the legacy platforms or the older devices or older browsers. So YouTube does this kind of uh, compression encoding, right? Then there is a one advanced VP9, and there is a latest one AV1. So here, just for example, if after the compression one video gets converted into 5 MB, here the compression will be higher, it will get converted into the 3.5 MB. However, it will give even more compression of 2.5 MB. Okay, and it will try to impact the quality of the video as well. And it will what it does, I mean, definitely it is going to compromise somewhere, right? So it just try to remove the duplicate information, try to remove duplicate information. Let's understand what kind of duplicate information. So in one video, right, there are multiple video frames. High definition, there will be too many frames, right, with very minor changes. So it smartly what YouTube does, it just removes some of the very close frames in order to reduce the size of this video. Even at the same time, it's not going to compromise with the video quality, not much. Okay. Similarly in the colors, so generally in colors, any image will be or video will be gets created using the RGB color coding. So and every color coding ranges from 0 to 255, right? So suppose R, for one image R value is 100, B value is 190, and G value is let's say 95. So what it will do, it will just reduce I mean just suppress it a little bit in terms of the coloring, and your eyes will not be able to notice these changes. So suppose 100 to 99, it will reduce this red color component little bit from 100 to 99, and then it could decrease to the 197 something, 94 something, right? And that's how some of the information where it is going to compromise, but it is they are doing at which level, which is very minor, and can be neglected easily, and our eyes are not able to capture those things. So that's how they are trying to just remove these redundant informations. Okay, these redundant informations, and trying to reduce the size of the videos. And then after, as a next process, just a minute. Then as a next process, a segment is a one step which comes into the picture. So suppose this 10-minute video that I have created, recorded, it will then get further splitted into the small segments, like 5 seconds clip, 5 seconds clip, right? Many 5 seconds clip. So you can just assume a big movie got splitted into the smaller clips, right? And these are nothing but I will say the streaming outputs. I mean I mean these are the actual I would say the video components which got streamed to your device, because it is not something that when you are searching for a video, playing a video on your YouTube player, it will just load the actual I mean uh, full size video, right? So what I'm trying to convey, so when you are just playing some video on the your YouTube player, let's say, or browser something, right? So there you might have noticed. So let me see, this is the YouTube player. So this will be the pointers which will tell you this much of the video is already played, right? Some videos are, some particular video is just buffering, streaming, right? So when it's streaming, actually these 5 seconds clips are coming here, and getting played for you, right? And you also might be noticing that uh, your video player is able to play till here, right? Till, let's say, 1 minute. Okay. However, this 5 10 second video is already buffered. That thing you might have noticed, right? So this buffering is something is coming with respect to this small clips that we have stored, okay, on this YouTube server. So the actual video of 700 MB get stored in form of these small segments of 5 seconds clip, basically. Okay. And again, that will be the package for the adaptive streaming. So let's understand the adaptive streaming as well. So what is adaptive streaming? So as a part of adaptive streaming, what happens, see, every person, whoever just consuming this information from internet, suppose from YouTube, so their devices could be of some old, some new one, some more advanced one, right? And they will be having some internet connection as well. Suppose he is using Wi-Fi, that person is using 2G, 5G, okay, or something, or broadband. So the internet network bandwidth is varying here. It's not constant. And even the device on which this video is getting rendered, this is also different. So what adaptive streaming says, that we already created original video, converted original video into the uh, different version of videos, like uh, 1080p video. The original video gets converted into the different pixel video, like this 144p or 240p or 4K video, right? So those things we are doing. And even we have done this segmentation as well. So these 5 second clips are available with respect to every definition of video. I mean, for 1080p video quality also, we have this 5 seconds clips available, and for 7 and for even 480p or 720p video quality definition clips are also available. So what adaptive streaming says, suppose initially the speed was good, right? So it will try to render the 1080p video, but underneath it will bring the these segments only, right? This smaller 5 second clips only that will be running. And if it's fine, there is a network outage, or not outage, if the internet speed got suppressed or got decreases, in that scenario, it very smartly what it does, you might have noticed, from 1080p it got adjusted to the 460p video as well automatically, right? But it will not stop, or it will not happen like it's started buffering, right? And you have bad user experience. How That's how smartly YouTube is working underneath to give a better application experience to their end users. So that is feasible with the with the help of adaptive streaming. So what it does, If the speed is good, so it will buffer with the 1080p video streaming. And if internet speed reduces, so in the blink of your eye, what it will do, it will just start rendering 460p video quality in your video player, and you will not able to, I mean, realize that how without buffering how things are running smoothly. Okay. And again, when the speed increases of your internet, again it will switch from a 460 to 1080p video quality video, right, to give you this kind of better, I mean, video experience. So there is a concept of adaptive streaming ladder. Let me explain this one. There is a concept of adaptive bitrate bitrate ladder. So this adaptive bitrate ladder, what it does, so just consider as a ladder, and suppose 1080p video quality is on the placed on the topmost position of this ladder, and these are the steps. Then 720p, then 480p, then 360, then some 240p, then 144p. Suppose your video, your Wi-Fi is running smooth, or your Wi-Fi is running smooth, and in your device YouTube is buffering properly, right? So it started with 1020p. Suddenly your Wi-Fi speed reduces, right? So as part of adaptive bitrate ladder, what it will do, it will see the it will go and check for the other video clips of 5 second, which is nothing but in segments, available for 720 pixel or of that quality, right? It could be 720 or 480. And as per the availability, because it is not mandatory, YouTube will be creating different version of uh, videos covering all the video qualities. It may be the situation that it only for your video upload it only create the 480, 360, and 240 only, not the 144 one. So as per the availability of those segments in your storage, right, it will try to render, it will switch from this to this. If this is not available, then it's well and good, no issue. It will go and pick 480 pixel one, and then start streaming there to give you a better user experience. Okay, then again, if the speed increases, it will again switch back from here to there. Okay, that's how the adaptive bitrate ladder concept work, right? If the things are working well, it will enhance your video quality, and just try streaming the segments available. And if the video quality is not good, it will just reduce it to give you the better user experience. Because if your just video is buffering like round and round, right, it is not a better user experience. For that, rather than buffering, it tries to reduce the video quality and start rendering continuously. That's what the whole idea. Okay. And here I'm talking about this manifest. So this comes under the the what kind of protocols, that YouTube is using. So YouTube is basically using two type protocols, that is HLS and DAS. HTTP live streaming, then dynamic, I think this is adaptive dynamic adaptive streaming over HTTP. Okay, something like that. What it does, the main idea is HLS is different kind of protocol which is basically used for the Apple devices. So the devices which is iOS based, be it iPhone, be it iPad, be it macOS, be it Safari browser. So YouTube also underneath creates this type of files, which is HLS protocol enabled or that are enabled to run on iOS devices. So for that they uses the HLS protocol, and they create the file with that extension. And similarly, it also create the file with a .mpd extension as if they are following DAS protocol, which is primarily used for the other things like smart TV, and for many more. I mean, Chrome browser and even this Android devices. This is very popular. Okay, so under this segment also get converted into this manifest file, and this is something which will be which will be gets as a part of those video streaming component to your browser, because from browser when I will try to uh, run any YouTube video, right? So this browser send the information to the YouTube server that what device that user is using and what browser, okay, and what enter all those things, and accordingly it will try to pick this .mpd file or .m3 u8 which is which is compatible to the Apple devices. Okay, that's how the whole process works. Then the storage layer comes where YouTube store the original sources as well this segments, this manifest files, right? Nothing but this dash compatible file or HLS compatible video clips. Similarly, after that, in the YouTube, you might have noticed for any video there are some title, then there is the like, subscribe, right, comment, and the this like count stats. These all information are nothing but a metadata, meta information. This got stored in the big table. Okay, there are other alternative as well, but for the explanation, I've taken a big table for the data warehousing. And here in the big table, we are storing this meta information or storage path of that video and the states like the how many counts, how many shares, all those things, right? Then it goes to the CDN something that I told you, because for every hit it's not like that the request goes to the original YouTube application hosted on the let's say US servers, US data center. It basically for I would say research says, the market study says for 98.5 to 99% the information get retrieved from the cache inside, from the cache got hits for these many requests. For only 1 to 1.5% requests which are new, for that actually request goes to the original app, and from there data got retrieved and loaded to the those CDN edge devices, and then it got populated to the user device. So that's the whole flow. And then here the viewer is like making those requests, and through the CDN those requests got served. So that is the complete workflow, the underneath mechanism of the YouTube, how it works. I hope you like the explanation. Okay, all right. So after that, let's jump to the capacity planning part, because that is pretty much important. Let's see if I have missed anything. I have just talked about these things. Video compression covered, architecture and the streaming protocols, this HLS one, and then das one I have covered. Then why CDN is needed. Let's talk about the CDN. In the video flow I have explained you, right, how the request made. So let me just quickly explain you this as well. I hope I have explained these things from viewer. This YouTube video search. Go to CDN, and for 98.5 to 99% of the time video got retrieved from this CDN servers. CDN H, because content delivery network is nothing but a group of the servers hosted in particular regions, and from there this information will get retrieved and streamed to the viewer YouTube player. That's how the things happen. And for 1 to 1.5% of the new searches, we are suppose, because suppose viewer is from India. However, so this is suppose CDN for the US region. Similarly, there will be CDN for the European region as well. European. Okay. And suppose this is well and good. This similarly for the Asian region as well. This CDN will be hosted. And suppose here in particular city of US, this application, YouTube application, is hosted, the setup there on their data center, some Google data center. Now for 98.5 to 99% of the requests, where for this much of the requests, mostly data will be retrieved from these edge devices, these edge servers. Okay, because for those many videos they got copied to these edge devices, so that uh, because the more demands come from the more popular videos only. For very rare videos which are not majorly searched or newly added, for those what YouTube does, okay, if we are making the request, so what it does, those requests will go to the US, this server, the actual server where this original application is hosted. It will retrieve this information. It will take time, I know, and this will get copied to the this Asia region edge devices CDN network. Similarly, others as well, so that in case now Raj is making the request from India, if Kamal is making request from the European region, they are also, it need not to do the same thing again. That retrieving the data originally from the original YouTube application, then responded back, right? So one time when this new request happen, this data will be retrieved and stored on the this CDN H devices, H servers, and then so that in first request the response will be slower, but going forward those response will be improved. That's how this whole CDN in with even the video uh, video requests happen. See, this is about how video reaches the user. Okay, anyways, I think for the video reach, I think I have explained you already as a part of here, right? How this video reaches. So this is the explanation, guys. So here I already explained how video reaches to the how video reaches to users whole life cycle from upload till viewer. Okay, what internal things happens underneath this transcoding. This is something important you need to just keep in your mind. Okay, all right. Okay, I think everything I covered. Let's jump to the capacity planning. That is pretty much important aspect. Okay, let me open the sheet. So yeah, here we go. So this is the Excel sheet that I have prepared, this spreadsheet for the YouTube capacity planning for the more realistic infrastructure sizing model. So guys, I was talking about that there will be some of the assumptions that I got to know from the market research for this particular type of platforms. I mean, when the requirement comes to create a mini YouTube a platform which is similar to the YouTube with lesser functionality. So the idea is very clear that we have to use similar kind of metrics in order to do the capacity planning in more efficient manner. Okay, so these are the assumptions like daily active users. So market research says YouTube has 2.7 billion uh, MAU means monthly active user, and DAU means daily active user. Assumption is 40% of the, sorry, 74% of the MAU typically. Okay, so this is the source from the Alphabet or YouTube official stats of 2025-2026. So that's what I have done as a part of market research, and these are the basic stats, the starting for starting matrix in our hand, so that we can do the further calculation for each and everything. Okay, so for the daily active user, this is the count. Similarly, the total watch time per day, if you look at, so this is something 1 billion hours, 1 billion hours per day. This is the total watch time per day. Then the video view, total video view per day, if you look into that, so this is a 5 billion video view per day reported across 2025 industry stats. Okay, then what is the video uploaded per day? So these many hours. Okay, so like it's like 7,20,000 hours per day. This much I mean size of the videos are getting uploaded on per day basis. Then average video length, if we look into that, so I have also taken the consideration of 12 minutes to explain you. So 12 minutes is something, 12 to 15 minutes are the ideal size of the video across the globe. Then the peak average traffic factor, I'm taking 3x. So as and when I have to calculate for the peak scenarios, peak storage or peak traffic, okay, peak CDN, so everywhere I will be multiplied it by 3x factor. Then seconds in the day, that is 86,400 seconds, that is the constant one. And then other assumption in respect to the video encoding in the storage assumption, for the average source upload bit rate, it is a 8 bit, that I was explaining that for 1080p video average bit rate is 8 mbps, so that is very ideal. And for, if we increase the video quality, go to the 4K, I think it ranges from 16 to 24 mbps ranges, and vice versa. And then there is a adaptive bitrate ladder that I was explaining, right? For that, it is the uh, this is how it's it is the this is the weighted sum, considering every quality of video, be it 144p, be it 240p, be it 360, 480, 720, 1080. And then the average bit rate for this ABR ladder, it comes as the 8.9 megabit per second. Sorry. Then transcode compute cost, so this is something we taken into consideration as $0.015 per minute. So the transcoding is the main important phase, the process or activity of YouTube, which is the heart or the mind of whole YouTube application, where most of the expenditure will come. So this is the place where most of the her money got burned or spent, I would say. Then there is a matrix called metadata index overhead. So there we talk about keeping the meta information like video title, the like comments, the video path, right, the stats like count, number of shares, all those things. So that overhead is 5%. Okay. Then replication factor, we are taking 3 for the scalability or fault tolerance situation. Then the average delivered streaming bit rate. So while streaming, right, at the user end, if you look into on that, so the average speed, the delivered streaming bit rate that you are considering, that is 3 mbps. Then the CDN cache miss rate, that is 1.5%. So I already mentioned the most of the requests that comes from the user, for 98.5% to 99% requests got served. However, for 1 to 1.5% of the requests which are new, for which the request goes to the original application. So for that we are considering 1.5 as a miss rate. Then storage retention period, so this is what I'm considering, 5 years. So YouTube is considering retention period for your videos as a 5 year. Then the storage, standard storage cost, so what YouTube consider, $0.020 per GB per month. This is the standard that YouTube is following in order to calculate the storage cost. Then there is a CDN egress cost. This egress is nothing but the server you're talking about. That is a group of server that comes under the CDN content delivery network, right? For every reason. So that egress cost or CDN cost, the standard which YouTube has defined is $0.020 per GB. So these are the consideration assumptions that I concluded as a part of the market research, right? This is all, I mean, similar way, my suggestion would be for all of you, that whatever the project or whatever the client requirement or the personal project you are working on, go ahead and do the market research. And believe me guys, almost everything that you're going to build or planning to build is available somewhere on the world. It built by someone, anyone, anywhere, somewhere. Okay, somewhere things are available. So the only thing you have to do, you have to go and do the market research. Nowadays things are very much easier with the help of AI tools. So go there and do that research. And now the estimation parts come. So in the section C, I'm talking about the daily upload and the transporting pipeline. These are auto calculated. I have put the underline calculation for that, but still, let me tell you, this video upload per day, right? In order to calculate video upload per day, so this is nothing but total upload hours into 60. Okay, and then the average video length, which is nothing but 12, right? So this is the total uploaded hours. If I'll go there on the on here, video uploaded per day, right? That much hours of video people are uploading on the YouTube platform, multiplied by 60, because this is in hours, so it got converted into minutes, then divided by the average length of the video, so it comes to the this much. So this much videos we are uploading per day, right? So this is pretty much important as a client and as a developer, you to know, to design a scalable system. Then average source file size per video. In order to calculate that, the formula logic is that you need to just consider source bitrate mbps in mbps, right? And for that calculation, what I'm doing, so see guys, if you look at what all fields I have considered here, so if you go there, average source uh, upload bitrate multiplied by, so this is in mbps. So what I have done, I have just multiplied by 6 zeros. Okay, it will be 1 followed by 6 zeros to get converted into the bytes. And then this is into the bits, so I need to divide by 8 as well. So that's what I have done, it divide by 8 to get converted into the bytes. And then I have just multiplied this average source upload bit rate with average video length, and that's what it gives me, this value. That's what I have done it, see. And then average stored size per video. So this is the I mean, here I'm considering the ABR ladder as well. Okay, so here whatever the calculation I will be doing, considering the ABR ladder total bit rate. So here what I will be doing, I'm considering ABR ladder total bit rate. Initially I was considering average source upload bit rate, which was 8 mega megabyte megabit per second. Now for the ABR one, I'm considering ABR letter total bit rate. Again, it will be multiplied by 1 followed by 6 zeros in order to get converted into the bits, then divided by 8 to get converted into the byte. Then it will be multiplied by the average video length, and there again into the seconds I need to multiply it by 60. So that's how, if you look at here, so I have just computed this video uploaded per day, then average source file size per video, then average stored size per video considering ABR. So in ABR, I mean, underneath it will be creating the different versions of the files, right? And not with 1080 pixel only, it will create the 461 one as well, 144 p as well, 4K as well, right? So considering those many version of video quality files, this storage will increase. Then total storage will be the actual one, and then this ABR ladder one. Then we just added this. See, this one I have added 28, 29, right? Then we got this value. Then uploaded in just bandwidth average that I have to calculate. So here for the calculation, basically I have to what logic says total source byte per day, total source byte per day, and do 8 again. It could be in bytes, I need to convert into the bits, then per second per day, total source bytes. For total source bytes, I have to go, see, this is what it multiplied, C27 and C28. So these many videos uploaded per day, and the average source uh, average source file size, this got multiplied, right, and divided by 36,400, 86,400 to get converted into the those seconds. Okay, so this is pretty much straightforward if you look into the calculation. I hope this logic is clear. I mean, I have given this logic as well. In order to calculate the uploaded in just width, we have to basically multiply the video uploaded per day into average source file size per video, then only we'll get that value, right? Then we have to convert into the megabits and the second conversions that we have to take in. Then I have converted from to GB, then I total ingest bandwidth, see, this is the 240 Gbps, this much. Even for the upload, in order to support the upload activity, video upload across the for this many daily active users across the globe, this much bandwidth, upload bandwidth is required to I mean YouTube to work properly, efficiently. Okay, that is too much. I mean, we are not having 100 Mbps speed in our home or office, and here we are expecting the expectation is 240 Gbps, right? That is too much, because we are designing a very heavy system. So that is something very important we need to think of. Then daily transcoding compute cost as well we are calculating. Here we are just considering this, see this one, just a minute. So I'm just considering this one, just this is the total uploaded minutes per day multiply cost per minute to transcode. Okay, just a minute guys. So for doing that calculation, daily trans daily transcoding compute cost, it says C8 C17 C17 is something where we are transporting costs here, we are calculating. We are just multiplying this thing with C8. See, with total, see, a total video we are uploading, right? And then this much hours of video. And again, these are in into the hours that we have to calculate the minutes of second as per the requirement. But again, there is one thing, transport compute cost. So for that many videos, that much hours of videos, what would be the transport compute cost? That's how we are just multiplying and calculating it per day. Okay, so similarly I have done the storage growth calculation, the daily raw video storage this much, then daily storage growth inclusive metadata overhead also I'm just including here. Okay, because for the metadata overhead we are considering sorry, this 5% metadata overhead in terms of the storing the title information, video path information, hit like all those content information. Then similarly the daily storage growth, that's what we are just concerned about. So if we know the total storage growth including the metadata overhead, we just converted this byte into terabyte and see this much is the per day daily storage growth, right? So accordingly we have to scale our system. Yearly storage growth raw, let's say this is this much TB per year. It is a huge system altogether. Yearly storage growth, see this much petabyte. And then storage footprint with replication. So this got multiplied with 3, right, with the replication. So this got just multiply this by 3, we got this number. Okay, see, this is how it's coming. We are just multiplying 3 replication vector. Then storage footprint with replication retention period, I'm just considering 5 year. So now per year, this much 5 year, this much terabyte of size, terabyte of data size would require, storage cost would require to retain those videos for the next 5 year. Similarly, if we are just calculating those retention cost in terms of the storage for next 5 year in petabyte or EB, right? You can see all these values, right? So I mean these are in different units. These are the only difference, but these values are too huge, and we are getting those services freely available, right? See, I mean they are making money through the ads and all those things, but this is the reality. They are managing very huge system. See this much of storage requirement, compute cost requirement, this much ingest bandwidth requirement. Without that, I mean, if you're not able to equip with this much of network bandwidth, yeah, I mean, you cannot hit the YouTube, and you cannot able to upload the video on the YouTube server. Similarly, for the CDN streaming, we are calculating these values, total streaming per day. We are calculating. So this watch hour per day multiplied by the 3600 seconds and multiplied by blend bit rate as well. So these are the logics I'm applying here. Then total streaming uh, in petabyte per day. Let's see this much streaming data right per day. Then average total streaming bandwidth is this much. We are converting into the TBPS. Then it's coming as a 125 terabyte per second. Terabyte, terabit per second. It's not byte, basically. So average total streaming bandwidth for to expedite with the streaming of your videos, right, without giving the issue of it keep on buffering and not able to retrieve or play that video from the YouTube server. YouTube need to have 125 terabyte per second network bandwidth. Here we are struggling to get 100 MB, but to build a YouTube kind of giant system, you would require 125 terabyte per second network bandwidth. Then for the CDN, basically, I have done the calculation here. I'm just uh, I mean, just adjusted the catch miss rate, which is I'm considering 1.5, I believe. In that case, what will the CDN server bandwidth would be required? So that calculation I have done. Then the and this is the origin fetch bandwidth, then average. See this average view per daily active users. That is very interesting here. What we are doing, we are just the total views per day we are doing total views where is total views per day divided by this number, and we are getting this number of 2.5 average views by daily active user. Then average watch time per daily active user, so 30 minutes is the average watch time. Okay, the total watch time divided by this, we get this number. Then similarly the peak traffic estimation we have done. uh, so there I just multiplied by 3. Okay, so the average terabit per second multiplied by peak factor. I'm just multiplying with 3, but the average total streaming bandwidth, which is 125, I'm picking up this and multiplying with 3. That's how we are getting this information. Similarly for the CDN as well, this value get multiplied by 3, this value get multiplied by 3, you get this number. Oh, peak origin fetch bandwidth. Okay, this origin fetch average origin fetch bandwidth. Okay, average origin fetch bandwidth in gbps multiplied by peak factor. So here origin fetch bandwidth is this one, just multiplying with 3. That's how it's. Then peak concurrent streaming. For the concurrent streaming, okay, what it says. So this is a peak one in Mbps divided by average per streaming bit rate. Then it will give the order of magnitude concurrency estimation. So here this peak total streaming bandwidth is in TB, just multiplied in by 1000 to make it basically uh, in gbps. And then what else I have done. So what it does, C60 peak. Okay, it says peak total streaming bandwidth multiplied by 1000. Okay, got it. Divided by C 20. This is okay, average delivery stream bit. So basically I have to divide with average delivered streaming bit rate in order to calculate this concurrent streaming. Okay, and similarly for the peak total RPS, and that's how we will be doing the calculation, guys. Nothing but just multiplying it with 3. It is what it doing view per day per uploads per day. Then okay, so what it does, uh, peak total RPS is nothing but requests per second. So the requests are coming in terms of this watch and view. Okay, we are just adding view and then uploads per day. Okay, upload where upload. Okay, this one, and then we are just converting into, I believe, into minutes or so per second. Okay, so accordingly I will be converting those hours into the second and divided by 86400. So this number will be coming. So that's how the peak total RPS will be calculated. And then for the monthly infrastructure cost estimation, see the storage cost. This is something the financial planning we are doing for the application, right? We know that after doing this estimation at storage level, at CTN level, at network bandwidth level, right, or even in the case of YouTube, it is a transcoding cost as well, right? So doing all those calculation, we understand per month storage cost will be, see, this much, this much dollar, transporting computer is this much, CDN, the cost will be this much, total estimated monthly cost is this one, where we have just added all those things, right? And see, this number is coming, right? Then estimated annual infra cost multiplied by 12, this is yearly cost. And then just implied cost per daily active user, then the monthly cost whatever we have, this divided by the daily active user. So it's coming as $0.7295 per user per month. This is the actual cost is going to come to serve a user per month of that scale application, where we having 2 billion plus users at monthly active user level, right? So the MAU and MAU and DAO, the things we are talking about, if we have the consumer base of that level, right, where we are dealing in the 2 billion or some in that big numbers, so definitely the per user cost will in terms of the uses of the platform will come as the $0.7295 per month, which is again the nominal one. And this is why this is coming nominal, because we are doing each and every estimation properly, and that's where we get the sense of understanding that even to develop or design this complex type of system as well, this will not be too much costly for per user level, but again need to understand where the most of the cost is going. This is the I mean expenditure from the client side, right? They have to bear, so they have to take the call. Are they in position to invest that much to create a system of to run at that scale? if if we want that application to run at that scale, definitely the expenditure will be more at the infra level on those costings. So that is pretty much important that client get the understanding, and this whole exercise is the day zero activity. It's not like that we get the requirement started doing the implementation of the project, right, without knowing all those financial constraint, right, the budget constraint, right, the risk on all those things, we cannot proceed ahead with. It's not like that after 1 month of the development we got to know the client do not have the budget to support to build that kind scale of application, right? So that is pretty much important. And then for the future growth aspects as well, we are considering these many metrics, and given this 3 year projection, this is the values. For the 5 year projection, this will be the value. For the 10 year projection, this will be the values. So that's how easy this is, but it requires a lot of background efforts, guys. That's it pretty much from my side as a part of today's session. I have covered pretty much everything which is required to you uh, do the design for a system which is a YouTube like platform. And using the learning from this video, you can apply this learning to the other application or product or projects capacity planning, and you will feel confident because now you're aware about all these jargons, and you can feel more confident about capacity planning, which is pretty much essential. So with that, I'm signing off, and remember guys, keep learning, keep growing, and keep building together. Thank you.